Welcome to today's Explainer. We're jumping right into one of the absolute most terrifying and honestly fascinating biological mysteries out there. We're talking about a disease that, if left untreated after you're exposed, is almost 100% fatal. Literally one of the deadliest diseases known to science. But as we're going to see today, the actual reason it kills you, it's just a bizarre biological accident. And that brings us to the really wild central paradox we're exploring today. Rabies is a guaranteed killer if it runs its course, right? But here's the crazy part. The virus doesn't actually want to kill its host. Death doesn't do the virus any favors at all. What rabies actually wants, its true biological goal, is mind control. It literally wants to hijack the host's brain. Now, to understand how and why it pulls off this sci-fi villain move, we kind of need to look at how diseases normally operate.
So let's look at Section 1, the pathogen playbook.
You'll notice a massive contrast in strategies here. Pretty much any pathogen, whether it's a bacteria or a virus, has one main goal, right? To replicate and spread to new hosts. Normal pathogens use some pretty gross physical strategies to do this. They might make you sneeze or cough everywhere, cause oozing sores, or bring on a truly poop-tacular amount of diarrhea. The whole game plan is basically physical expulsion of the germ. But rabies? Rabies takes a totally different path. It completely ignores physical expulsion and instead forces profound behavioral changes. It actually alters the mind to make the host transmit the disease. To figure out why on earth rabies resorts to literal mind control, we have to look at how it transmits. Rabies is transmitted exclusively through saliva. So for this virus to win and live on, that virus-loaded saliva has to make its way directly inside a totally different critter's body. It can't just be sneezed into the air and inhaled. It basically has to be physically injected into the new host. Which brings us to Section 2, a slow, stealthy journey. So most pathogens, once they get past your body's defenses, they jump right into the bloodstream, like it's a superhighway. It's super fast and gets the virus everywhere. But the bloodstream is heavily patrolled by the immune system. Rabies totally avoids the bloodstream. Instead, it slips into the nervous system and travels straight through the nerves. This is an absolutely brilliant evolutionary tactic because it keeps the virus completely hidden from the immune system's radar. Plus, those nerves provide a direct, uninterrupted route to the one place rabies desperately wants to be, the brain. But, there's a huge trade-off for all this stealth. The virus only advances maybe 3 inches a day. It is just an agonizingly slow, microscopic commute. Day after day, literally inch by inch, the virus creeps up the nervous system, totally undetected, slowly inching its way right toward the host's control center. And eventually, that slow journey pays off. Welcome to Section 3, hijacking the host's brain. Once it finally hits the brain, the rabies viruses just start multiplying and building up. And while scientists are still piecing together every granular detail, we do know that the viruses bind to specific receptors that brain cells use to talk to each other. Basically, rabies intercepts and seizes total control of the brain's internal communications network. And the result? The host suddenly becomes way less fearful and highly, highly aggressive. For animals like dogs and bats, this hijacked brain state means they're way more likely to approach, attack, and bite another potential host, passing along that infected saliva. Boom, the mind control is complete. Which brings up a really fascinating question, and you might actually be wondering this right now. If rabies causes this mind control in biting, why don't infected humans go around biting people like a bunch of zombies? Well, the crucial point here is a biological concept known as a dead-end host. Look, humans infected with rabies definitely experience the brain hijacking. We absolutely act differently, often getting extremely agitated and anxious as the virus takes over. But humans just don't have those strong hardwired instincts to bite as a primary form of attack or defense, Not like dogs or bats do. Because our baseline instinct to bite is just so incredibly weak, the virus can't force us to transmit it through our saliva. So when rabies enters a human, the chain of transmission just stops. We are a dead-end host. But just because we're a dead end for the virus doesn't mean we get off scot-free. That leads us to Section 4, the collateral damage. The brain is the control center for literally everything, not just our behavior. So when rabies interrupts those neural receptors to amp up aggression, it basically breaks the entire communication network. The cells just can't talk to each other. And without those signals, the brain can't tell the lungs to breathe. It can't coordinate the heart to pump blood. It can't tell your muscles to move. All the vital systems just immediately spiral into complete and total disorder. Everything breaks down so rapidly and, well, the host dies.
And that right there is the tragic paradox we talked about at the start of this explainer. Rabies doesn't gain a single thing from the host dying. I mean, once the host is dead, the virus can't spread anymore. The death of the host, whether it's a bat, a dog, or a person, is literally just serious collateral damage. It's just this clumsy, fatal side effect of the virus being a bit too aggressive when it interrupts the brain's normal operations.
Given how devastating all that sounds, you'd think a bite is just an automatic death sentence. But thankfully, we have Section 5, How to Survive Rabies. Ironically enough, the exact same mechanism that makes rabies so successful is actually its biggest vulnerability. Remember how we talked about the virus creeping up the nerves at just a few inches a day to stay stealthy? Well, because it moves so unbelievably slowly, it actually gives modern medicine an incredible advantage. The biggest thing you should take away from this is that rabies is one of the only deadly diseases where you can get vaccinated after you've already been infected. That long, slow commute up the nervous system gives us a crucial window of time. If you get the post-exposure vaccine quickly, the medicine can actually train your body's immune system to recognize and hunt down the virus before it ever makes any real headway toward the brain. You can literally intercept the hijacking before it even starts.
As the source material perfectly puts it, control it before it controls you. But, it really does leave you wondering, if a microscopic virus can so perfectly hijack a mammalian brain to completely change its behavior, what other pathogens might be quietly pulling our strings right under our noses? Thanks so much for joining me for this explainer, and definitely keep that curiosity alive until next time.